Hello. Today we're going to be working on slope-intercept form. We're going to be needing to find slope and graph lines that are in slope-intercept form. So slope is going to be the rate of change. So you're looking at how fast a line is increasing or decreasing. So what is that rate of change? So you're going to have some sort of line here. So slope, you can do many different things. You can do the rise over the run. So visually, you can pick any 2 points on the line, and you're going to do your rise first and put that over your run. Now, that's also known as the change in y's over the change in x's. So your y values are the rise, your x values are the runs because your y's are up and down and your x's are left and right. So if you want a specific formula, it is going to be y2 minus y1 over x2 minus x1. And that is if you're given 2 points x1, comma y1 and x2, comma y2. So this is the formula way to do it. Otherwise, you can visually look at it and just count your rise and run if you'd like. So now when you actually calculate the slopes, there are many different ways that can come about. So there's 4 different types here. So the first one is going to be a positive slope. It increases from left to right. The next type is going to be a negative slope, which means it's going to decrease from left to right. You could have a slope of 0, so that's going to be a horizontal line, or you can have an undefined slope. So looking at all of these, if you were to use a slope formula for a positive slope, it could be a fraction or a whole number. As long as whatever you get, you end up getting a positive. Even if it was something like -4 over -3, that still simplifies to be a positive slope. For your negative slope, it could happen many different ways. So as long as when you simplify your answer, any of those have a negative sign and they don't simplify to a positive, your line would fall from left to right. When you're doing your slope formula to get 0, you will end up with 0 over some number. It could be 0 over 2, 0 over -50. When you get 0 divided by some number, that's going to simplify as 0 and give you a horizontal line. Versus undefined. Undefined slopes happen when you have any number divided by 0. That's going to give you an undefined slope and therefore a vertical line. So those are the 4 different types of slopes, and what happens is we can use those slopes to actually graph lines if they're in slope-intercept form. So for this one, it's going to be y equals mx plus b. So slope-intercept form, this is a big one. Y equals mx plus b, where m here is your slope and b here is your y-intercept. So this is slope-intercept form because you are given those 2 things in the formula. So looking at number 1 here, slope-intercept form helps us graph because if we can look at this and say my slope is 4/5, the symbol for slope is going to be m. So in this case, m equals 4/5, and my y-intercept is going to be at 0, 2. And so what we can do here is we can go up 0, 2 and put a point. B is your y-intercept, and that stands for begin. That's where you begin your graph. M is your slope, and that stands for move. So I'm going to go move up 4, 1, 2, 3, 4, and then over 5 and put a point. And up 4 and over 5 and put another point. Likewise, I can also go down 4 and left 5. So I can go down 4 and left 5 because the -4 divided by the -5 would end up getting a positive slope. Also, I can go down 4 and left 5, and I can then graph my line. So that line is y equals 4/5 x plus 2. So for the next one here, y equals negative 2x plus 5. My y-intercept is 5, so I'm going to go 0, comma 5. My slope here is negative, which means it's supposed to go down from left to right. So I'm going to go down 2, right 1, down 2, right 1. And I'm going to keep extending those points as far as I can on my graph. But I can also extend it the other direction by going up 2, left 1. And so after I've graphed my points, I just connect my line. So that's the idea of graphing from slope-intercept form. Now if you look at these next ones, they're not exactly in slope-intercept form. So what we need to do when that is the case is we need to take and write them in slope-intercept form, aka we need to solve for y. Now that might seem familiar because a couple units ago we took and we solved for variables and we had other variables in the problem. That's kind of setting us up here for this one. So we need to get y by itself. So for example 3, we're going to divide by 6. So I'm going to divide everything by 6 and get negative 5 over 6x plus 1, which means my y-intercept is 0, comma 1, and I can go down 5 and write 6 from there. I also can go up 5 and left 6 from there and graph this line that has a negative slope. So for my next one, in order to get y by itself, I first have to move the 6 to the other side. So I get 3y equals 3x plus 6. Then I'm going to divide everything by 3 and get y equals x plus 2. So I'm going to go up to 0, comma 2 on my y-intercept. My slope here, if there's nothing here, that means my slope is 1. There's an implied 1 in front of here, which means it's up 1, right 1, and down 1, left 1. So you plot the points and connect the line. So for numbers 5 and 6, now we can take it and work backwards. So we have given these graphs. We need to go ahead and find the slope. We need to find our y-intercept, and then we can write it in slope-intercept form. So again, the big thing here, y equals mx plus b. So we look at our graph here. It crosses at 0, comma 4, which means b is 4. My slope, I'm going to count. So I'm going to start at one point and go to the other. So notice here I'm going up 3 and I'm going right 5. So my slope here is rise over run. It would be 3/5. So my equation then is y equals 3/5 x plus 4. So let's try the next one here. My b value has to once again be 4 because I'm crossing at 4 on my y-axis. To count this, I'm going down 4 to get from one point to the next, and then I'm going right 8. So down is negative, right is positive. So my slope here is negative 4 over positive 8, which would reduce to negative 1/2. And my slope visually looks like a negative slope, so that works out. So y equals negative 1/2 x plus 4 would be the equation of that line. So 7 and 8 and 9 are all applications of this. So what I'd like you to do is pause the video and try them out and see if you can come up with your equation in point slope form. So pause and try them. Let's see how these went. So for number 7, you're told the slope and the y-intercept. So your b value is negative 6 and your m value is 2. For number 8, you know your slope is negative 2, but you have to go and you have to look for your y-intercept. So be careful with this one. Your y-intercept is where it crosses the y-axis. And so your y-intercept, when you work backwards, should be up at 8. So it should be y equals negative 2x plus 8. For number 9, visually, here's what's happening. Your x-axis is this one, and so it crosses at 7. And for your y-axis, it's down at -5. This is your b value. Now you need to go on the hunt for your slope here. So for here, we're going up 5 and right 7, which makes my slope 5/7. So the equation we should have is y equals 5/7x minus 5. Okay, so then we have just a couple of application problems towards the end here. So when you're reading these problems, it's in this section y equals mx plus b. B was your y-intercept, which is going to be the initial starting value for most of these word problems. M is your slope. This again was your rate. Okay, so with these ones, look for initial value and then look for a rate. So for Greg here, he's driving the remote control at a constant speed. The car starts 5 feet away. So this here is your initial value. That means your B value is 5. The speed here is 4 feet per second. So if this helps, when you see something like feet per second, this is your rate. And if you see a rate, that's going to be your slope here. So our slope here is 4. We're going to write the equation as y equals 4x plus 5. Now we want to use our equation to determine when the car will be 35 feet away. Now this 35 feet could either represent x or it could represent y. Now looking at the problem above, the distance here was y, time was your x value. So since we're looking for when, we don't know the time, but we're told that it ends up 35 feet away. So we're going to plug 35 in for y, and we're going to solve for x. So we're using our slope intercept formula. And so we end up with x equals 5, which means 5 seconds later, then the car would be 35 feet away. So we have a couple of challenge problems here. We want to write the equation of the line that goes through those 2 points. So it has to be in slope-intercept form. So we need to know 2 things, m and b. Now we don't know either one. So what we're going to do is we're going to use our slope formula to find our m value. So we're going to do y2 minus y1 over x2 minus x1. Now when we do minus a negative, that double negative turns it into a positive. So 4 plus 2 is 6, and 3 plus 1 is 4. And that should reduce then to 3/2. But now we still don't know our b value. So in our equation, we have y equals mx plus b. What we can do is we can go ahead and say, I know my slope is 3/2. I don't know my b value, but what I can do is I can take either point. So I'm just going to take 3, 4, and that can represent x, and that can represent y. So I'm going to go ahead and plug in 3 for x and 4 for y, because now this is something I can solve. I get 4 equals 9/2 plus b. So if I subtract 9/2 from both sides, b ends up being -1/2. So therefore, my equation would be y equals 3/2 x minus 1/2. So go ahead and take a look at number 12. It's the exact same idea. Take a look at number 12 and pause the video and try to write your own equation first. Okay, now that you've tried it, here we get a slope of -2.65 and a y-intercept of 25, which means the gift card was initially $25 and she spends $2.65 on every medium coffee. So we're looking for her to end up with a balance of 0 on her gift card. So we're going to take this equation and we are going to solve for x. So we get 2.65x equals 25. When we divide, we get 9.43, which means she can buy 9 coffees overall, because we can't have that decimal. So thank you very much for listening. I hope it helped, and let me know if you have any questions.